Hi, my name is Jeff Perry, and I'm the manager of the WEBENCH team at Texas Instruments. Today I'm going to talk about WEBENCH Power Designer, and I'm going to give you a brief introduction to the tool. WEBENCH Power Designer is really an end-to-end design and prototyping tool. In step 1, on the left side, you enter your voltages and currents for your power supply. This would include your minimum input, maximum input voltage, your output voltage, and your current. After that, the WEBENCH tool will recommend different solutions for your power supply design. This includes the WEBENCH Visualizer, which allows you to optimize the design for small footprint, high efficiency, or low cost. In step 2, the design is created by WEBENCH. This includes the bill of materials for all the passive components that come with the design, and also the calculation of operating values such as efficiency and duty cycle. You can sub-optimize your design in this step, including choosing individual BOM components and even custom BOM components. In the third step of WEBENCH, you can analyze your design using the WEBENCH electrical simulator or the WEBENCH thermal simulation tool. In the last step, for Build It, you can get a custom prototype kit shipped overnight if you'd like to build the prototype. To get to WEBENCH, just go to ti.com and use the WEBENCH Designer panel on the right side of the screen. Simply enter in your minimum and maximum input voltage, your output voltage, and your current. Then click on the Start Design button in the lower right. Or if you have a specific part you'd like to use, you can go to the product folder for that part and use the WEBENCH panel on the right side. WEBENCH includes features such as electrical simulation. You can access that by using the top navigation bar in WEBENCH and clicking on the sine wave here. WEBENCH electrical simulation includes 5 different simulation types: Bode plot, line transient, load transient, startup, and steady state. This allows you to get the dynamic behavior of your design over different criteria. To initiate your simulation, just click the Start New Simulation button. On the right side, when your simulation is done, you'll see the results appear in the WEBENCH waveform viewer, and you can add additional waveforms by clicking on the different waveform icons at the lower part of the screen. Here's an example of a Bode plot simulation. On the x-axis here we see the frequency, on the y-axis we see the gain and the phase. And we can see here as the gain approaches 0, that's our crossover frequency, which is approximately 35 kilohertz. We go up here and look at the phase, which is coming in at about negative 140 degrees, and so we have about 40 degrees of phase margin for this design, which meets the criteria for stability. WebTHERM's thermal simulation in WEBENCH is accessible by clicking the thermometer icon in the WEBENCH navigation bar. On the right side, you'll see a recommended layout for your board. This includes all the passive components that dissipate power. On the left side, you can enter in different simulation parameters. This includes your operating conditions, such as the input voltage and output current, the ambient temperature in the top and bottom of the board, the copper thickness, the board orientation, and airflow parameters, including the velocity and direction. At the bottom of the page there, you can also enter in your boundary conditions for your edge temperatures. Here's an example of a simulation that was run using 2 different copper thicknesses. On the left side, you'll see that the low side FET is actually 117 degrees C, which is dangerously close to the 125 C operating limits. You can also see the effect of the co-heating there. The low side FET and the high side FET are relatively close together. This is something that the simulation will give to you that you cannot determine simply by using theta JA. In this case, on the right side of the screen, we increased our copper thickness to 4 ounces. That lowered the temperature of the FET down to 68 degrees C. To summarize, WEBENCH Power Designer is an end-to-end design solution. It includes online selection, simulation, and prototyping, dynamic design optimization based on size, cost, and efficiency. What I didn't talk about today was the WEBENCH Visualizer, which allows you to view dozens of designs at a time to get the best solution for a single power supply. Each design is optimized up front for efficiency, cost, and size. So for a company like Texas Instruments that may have dozens of different solutions for your design, that allows you to compare them side by side. WEBENCH Power Architect is a system-level design for complex multiple load applications. This provides different rail architectures, and each system is optimized for efficiency, cost, and size. And overall, WEBENCH tools save you time. Thanks a lot for your time.